Yeah, actually, Robert couldn't join us. He's busy in our offices, so it's going to be Thomas Haag and myself presenting the status of our Access 4.0 program. We're both sharing the role of the technical lead in Access 4.0, and I'm going to start a bit with what Access 4.0 is about for those who don't know. We've been here last time, and I think we brought only 2 or 3 slides that are the same. The rest is all brand new, so don't worry if you think it's going to be the same song as last time. We're not status quo. We're singing also new stuff. Actually, we wanted to do this from the balcony, but then it turned out maybe it's not a good idea. So it's really nice view from there, but maybe not for you. Okay, Access 4.0. So the title says it already. It says, okay, getting serious. But what we mean by that, this is not a thing where we just play around and do some innovation and do some POCs and then it's done. No, it's really serious. We want to introduce this technology into our production network. So we give you a quick recap, show you a bit what we think are good achievements, up to you if you also like that or not, and show some special highlights. And we appreciate any kind of feedback, either in Q&A, but maybe we don't have time enough. We're still around here. So if you have any feedback on that, it's highly appreciated. Okay, so Access 4.0, this is actually our mission statement. And this is, we try to make very clear in the beginning of this project that we have clear use case, which is not too small, but also not like covering every topic inside Deutsche Telekom. So what drives us is that we want to redesign the access network, and the criteria for judging whether the redesign is good or not is cost efficiency. It's the way we operate and how scalable it is, and that we provide the service, which is products for the gigabit area. This is the second slide that some of you might have seen already. So in general, what, maybe I walk over here, hello. This is a very simplistic view, but it has a very important message. So the one thing is we have different types of access technologies. And yeah, we know they are not harmonized. They should be harmonized. Many smart guys in 5G work on harmonizing that, but at the moment they are not. And let's see if we can harmonize them. But then we want to put a machine in the middle, which is in our view some sort of a mini data center distributed across the country that basically terminates these access circuits, provides local services in case there are some, and gives us access to the IP network where the other services are connected to the over-the-tops, but also the services that we provide, like our entertain platform. This is not a German diesel engine. Next time I'll replace this picture. It is supposed to be a really high performance, scalable thing that does the work. Actually, I came here with one of these engines. Anyway, one of the things that we do different compared to projects I have been in, Lothar, you don't need to take pictures. I'll send them to you. Unless you want to take a photo of me, right? That's okay. The thing that is new is that from day 0 or day 1, we had a cost model. So when we started this project, you can't, in Deutsche Telekom, you can't just walk in and say, hey, I want to redesign the access network, give me 20 people and a lot of money and a lab. No, this doesn't work. So in the beginning, we started already calculating the expected cost of the new technology. So what we did in the beginning was look at CORD, Central Office re-architected as a data center from the ONF, look at it, what's good, what's bad, get it running in the lab, try to figure out how difficult it is, and in the beginning it was not so easy. Now CORD version 6 is pretty easy to install. Back then, at least for me, it was not easy. But now it is, and then we looked at what's the key components in there. We do have a team that's doing design to cost. We got the guys in. Actually, I was also one of those in the beginning, and we did a cost case. And then we figured out, whoa, this looks promising. And that was the reason why we're doing this. We're not doing this because it's cool. We're doing this because it has a green cost case, and the potential for automation and rapid service delivery has become visible over the last 2 years. Okay, so with that, I'll hand over to Thomas.
Thanks. Hello, everybody. My name is Thomas Haag. I'm the architect in that project. So I would like to take you with me now what happens during the last year, what's new, and what's next. Hans-Joerg already told you that the scope of Access 4.0 is, and we cannot repeat it again, well, a lot, we have to repeat it, it's an extensive design to cost project for FTTH and FTTB. So that means it's always monitored and it's with a comprehensive cost model. And the design and the engineering is based on bare metal. We're using OCP hardware, so that means the switches are bare metal, OCP hardware, and of course the OLT, and a lot of open source software, and as well as very important merchant silicon. So we don't want to have specific ASIC designs here. Then the application of the data center principles. Hans-Joerg already mentioned the chord principles. Yes, we are doing some kind of chord, but we are not copying chord. So we are doing Access 4.0, and that's important to know because we need to adapt the technology and the use cases to our specific market requirements and our specific business needs. And that's what happens here in the Access 4.0 project. Of course, we have a clean IT architecture in place, which means we are following the Las Vegas principle. That means what happens in the PUD stays in the PUD, unless it needs to be exposed to the outstanding world. And if you look to the figure on the right side, you see in the blue box, this is a PUD, and the PUD consists of several components, like the OLTs, like the leaf and spine switches, and of course the yellow components. And this is a local management which exposes only necessary data to the central EMS. So not every event in the PUD is exposed to the outstanding world, only if necessary. And that's new. So the PUD is, let's say, more or less encapsulated, and it's planned to be installed 900 times across the whole network and run with a central EMS talking to the local EMS. So the objectives of the Access 4.0 is, of course, save OPEX and CAPEX, reduce the vendor lock, and that is also very important because it's not only the vendor lock on the boxes, we only want to have multi-vendor environment also down to the chip level. Very important also is to drive the automation. That means setting up a PUD and get it up and running has to be done in an automatic way. And also what is also very important is the time to market aspects. That means if we develop new services, we want to have the business logic and the software driving this business logic under our own responsibility in our own house. This increases the flexibility, and of course we are able now to change the capacity and to migrate our network more easily. Now A4 turned 2 in summer, so happy birthday. What has been achieved so far for the FTTH and the FTTB, and what is next. So you see 4 blocks here. The block number 1 is what's happening in our lab. So the real code running for FTTH and FTTB is running in our lab. So we are able to terminate multiple PPP sessions of multiple customers. We run all of our equipment on bare metal, open source, Kubernetes, and of course Volta. Our focus is on automation down to the customer. That means if a customer brings up the ONT, then the PUD automatically detects the endpoint, and all capacity and all configuration management to the service edge and the service delivery is done automatically. So this is running in our lab. And what has been done so far on the specification side? So we have a document shared among more than 30 experts, which is our feasibility study. This is the basis for our PUD. It's around 200 pages, and it's really recommended to experts. And of course, as Hans-Joerg already mentioned, this is escorted by a cost model and the cost model is green. That's one of the important aspects to drive this project forward. Another important aspect is that we are not doing everything by our own. We are collaborate with community, and that leads us to the next highlight. So we submitted an OLT spec, an OCP spec. There was an ONF community event in June 2018 where this happened. The code contribution for Volta, we also contributed on that, and we also drive the alignment with other operators on the same topic. And what happens now, we are in a process that we have an RFQ running for the co-development for partnership on the FTDH, FTDB at A4. This process, the request is already out, and we also already received the answers, and the evaluation is still work in progress. So the objective is to find a partner who shares our vision and wants to productize the A4 design. So what's next? I mean, probably some of you know the situation. Before you start an engagement, you have to prove and you have to check if you like the same movie, if you like the same food, whatever. So in the same situation we are here. So if we are looking for a co-development partnership for productizing the Access 4.0, we need somebody who shares the vision, accelerates the development, enabling the delivering mode, bring up the know-how in that joint work from both sides. And this is a process finding the integrator and the supplier role for A4. This has not been developed finally, but this is still work in progress, and we have to share the same vision on that. And then the test integrator role is also very important before you're going to the mass rollout. And of course, it's a continuous process in learning and improving methodologies. This helps to mature the new interplay between the various players, including the development and the communities. And well, this is in progress, and before we engage, we have to align here and that. So the objectives for this co-development and partnership is to develop and realize the test for this solution and the run. Of course, in a limited rollout, it's only a few samples by end of this year and beginning of next year. That means with a very, very reduced feature set, but just bringing it up in continuous operation. Having a general available release OLT, that means we are not focusing on a DT-specific hardware implementation here. This is applicable not only for the OLT as well as for the DPU. Then next step is to integrate the EdgeCore XGS-PON OLT and another white box OLT, because we are not only obliged to support XGS-PON, we also have to support the previous standard, the GPON. And what's also very important here is to integrate the RT-Brick software. RT-Brick software is our software for management, and we also have an implementation of our switching fabric. And thanks also to our Radisys colleagues, we have also to integrate their software here. And finally, of course, using open software wherever possible. That's our general aim here. So I would like to hand over to Joerg for the special highlights.
Thank you. Okay, so this is a picture of one of our prototypes. As I said, I came with a German diesel engine. I came with an A4 and it had wheels, but at the lab in Darmstadt we also have the A4 project on wheels. So we have set up our data centers as they should look like when they get deployed, but we've also put it on wheels and we can drive it around wherever we want. Pardon? Quattro, yeah. Tell my boss I need Quattro. So this is just a picture of, this is a snapshot of what we have today. I mean, you can, if you take a picture, fair enough, but it's not going to be exactly as it is here. That's going to be rolled out. So, but this is the proof of concept, and parts of this are actually running in our live network already. So we have a very friendly user trial, and one of our team members is enjoying a huge bandwidth at home and smiling since he has it, and it's already running, as I said, as an early field trial. But I mean, we all know that go into the field as early as you can, right? Because there's a lot of things you need to learn you don't know about yet, right? And we got stuck somewhere and worked on weekends, but now it's working. So what's inside? I mean, this is what Thomas nicely explained. This is how a schematic view on the data center architecture. This is how it looks when you put it together. Servers, top of the rack switch, management switch. Don't forget about the management switch. This is a top of the rack switch. Here's an open OLT, and voila, that's it. So I already mentioned this is inside. What's on the software side? It's not really carved in stone what we're doing here, but the main principle is covered already. So there's also a color code behind. The green stuff is open or open source. It's community based, and we want to commoditize that. We want to use the same components that all our friends at the other operators do, even our competitors. It makes sense to jointly develop this. The magenta, or maybe red magenta here, is what we consider to open source, and the black one is currently proprietary. We can talk about open sourcing it if it's of any help for others. Okay, let's go through this. Well, the switches and OLTs, they run Open Network Linux. Robert already mentioned we work together with Redisys and RT-Brick at the moment on this. RT-Brick does the routing stack for us. On the servers, we have Ubuntu Linux. Not sure if my friends from Red Hat are here. Don't get scared. But this is what we're using at the moment. We like reading books, so we have Kafka here. The message bus, the Kafka message bus, is something that came later on in, and it turned out this is not only cool technology, but we think that the microservices that we host inside these mini data centers, to have efficient communication between those and the discovery and the load balancing, sort of a message bus architecture is the right thing to do. I don't want to have like 10 different instances of the message bus running there, so there's also a need to consolidate. When I talk about microservices, the small components, you will see one example in 2-3 minutes. The microservices themselves, it's a limited amount of microservices. So, I mean, most of the talks here about orchestrating big data centers, lots of VNF third parties, this is not the case here. Those are tailored microservices that we develop, but still they need to communicate. We need Kubernetes to manage them. And we also have, I saw a presentation here yesterday, containers in VMs. Yeah, we had that. Actually, I was proposing that, and we took it off again. So we have native containers there. We don't have a VM layer in between. Device abstraction is an important point that I'll touch in a minute. We use the Volta drivers from the Open Networking Foundation. We have honors in there. One of the key things that we developed in-house is the service edge. Service edge means this is the subscriber-facing side of what you call a classical BNG. A BNG you can split into a router and the subscriber-facing side. And we have implemented that on bare metal switches, not only on one chipset, on 2 completely different chipsets. It's working. We have a lifecycle manager to boot up the pod, to do software upgrades. We know how we would do software upgrades, so we'll trigger PUD via the Las Vegas interface and tell them to upgrade, but none of the IT systems outside the PUD shall be involved in what's happening in the PUD. That doesn't make sense. Then we have a control plane function, Thomas will explain, and the EMS, and we use Grafana there. So that's what's in there. This will probably change when we're here next time, but this is what's on the menu at the moment. Thomas, this is yours again, and the animation is gone. So
thanks, Hans-Jörg. So it's not so easy to read this slide because they're pretty small, so I will guide you from the left to the right, and then on the lower, also from the left to the right. On the left corner, upper corner, you see the principles of our PUD. It's a 2-stage switching approach. That means the customer comes in on the left side if he turns on his ONT or his modem, And then the first decision is taken on the tier 0. This is the first switching where you make the selection where the customer belongs to. That means he can belong to either a wholesale segment or a retail segment or even a business customer. At that point, then you select which service edge the customer has to be connected to. There we have the retail, which is a mass market, the potato field. Then we have the wholesale customer, where we hand off to a partner. And of course, if you have special business services, we call it rose garden. If you want to pay for the rose garden, okay, then you can also serve roses here. The process, how it works from the technical basis, if you look to the right corner, on the green boxes, it's ONU and OLT. There the discovery happens. Then the discovery message is handed over to Volta and thrown to the Kafka bus. And from that, the event handler is taken the OMCI message, or let's say the open flow message coming from the PON side. It contains a serial number, it contains a password, and according to these credentials, you discover the access. You don't discover the customer, but you discover the customer access endpoint. If you have done this, then you configure your switching fabric towards your service edge. If you have done this, you are complete in setting up the path. You are not complete discovering the customer. This happens in the next stage. That means step B. You have an established path, and then the customer starts a session, regardless if it's PPP or DHCP, whatever. In our case, it's PPP because we are obliged to support PPP for the market. Then the customer is discovered by its credentials on the PPP, and then based on this, on the red boxes, there the communication to the platform control starts, requesting service profiles, requesting all service parameters you need. This will be provided to the PUD, and the customer comes into service. This is all done in an automatic way. You don't have any static configuration inside the PUD per customer. And of course, if you look to the right, this is an example of our code here, this page. And this is developed inside the project, and this is our own code for that. So this serves our business logic and will be developed further and in a continuous way.
Okay, thank you. A few words about hardware abstraction. We said that in the beginning you want to get or reduce the amount of vendor logs. It's not really about removing vendor logs, more about functionality logs. So I have also worked for a vendor, so I know the other side, and I enjoy working for a long time with various vendors, and it's not to continuously change them, but it's about the functionality log. So if you put something in your network that is a single point where everything needs to go through, you are tied to the functionality that this element provides. And you have seen from Thomas our small SDN application that was not so difficult to develop, that allows us to steer customers to different service edges. So that's one step towards being independent on the, let's say, functionality log here. On the hardware side, simplified, if you look at forwarding, at packet forwarding, you have the forwarding plane, and this means there are 3 different types of devices that do that. That could be NPUs, ASICs, FPGAs, could even be x86. They should come with drivers, and then we need an intermediate layer that is abstracting the hardware from what we're doing on higher layers. For instance, if you have a control plane application, this could be a BNG control plane application in a COPS model, control plane user plane split. It could be famous SX reference point in 3GPP or whatever is being developed in 5G. This will send a rather abstract request, like set up a flow from here to there, use these IP addresses. But when you go down to the silicon, you need at least one level of detail more, and that should be resolved by the drivers, and we need a framework to host these drivers. So and also resolve conflicts here. And then, once you have that, so what we basically need is a framework where we host these drivers. One of the incarnation is the Volta framework from the Open Networking Foundation. The framework itself is community-based, it's open source, and everybody, or at least the members of ONF that use it, say, hey, we agree to that. Please, to our vendors, if you provide us the drivers and give us a device that comes with the drivers, we can rapidly integrate that. And there's one company here that bought their device, and I'm really happy having seen that, and they integrated the driver, and it took them 2 days. So Volta seems to work. I'm not saying Volta is already fully developed, but it seems to work. So the thing is, we would like to have competition on the hardware, on the performance. I've seen the previous speaker from Huawei, really great chipsets, programmable, great. But please give us the drivers, right? Then it really makes sense for us, because then there's competition. Whoever has the coolest chips, the best chips, wins this game. And we are in a better position to integrate towards the northbound. If this works, and it does work for Volta in the lab at the moment, and also in the field, in a limited field trial, the main efforts we have, and everybody knows it, is the integration into our processes in the IT. The less I need to touch northbound here, the better it is. Okay. We're not doing this on our own. So we're not saying we're going to rebuild everything on our own, code everything on our own, know everything on our own. That's not going to work. This is a community effort. First of all, there's going to be us as the ones that want to deploy this. Then there's all the vendors we have are invited to join this, and many of them joined this already. Then there's a couple of new players, IT companies, startups. They're all welcome to join this. This is happening in Deutsche Telekom, but it's also happening inside the community. And we're both experienced standardization folks. We know how standardization works, and we know what's good about it, and we also know that they're a bit slow and it's political. When it's only about technology, I think the community thing is the better approach. So here are some examples where we are already active. The PUD API, the Las Vegas thing, right? That should be in ONF or ONAP. We are currently looking at where to bring that to. We're not bringing that. We're not like shipping it, throwing it over the fence, take it or leave it. No, we have to jointly develop that. That's something that's, for instance, happening in ONF in the SEBA working group or SEBA project. Service Edge API, the same thing for a Service Edge, so the BRAS part. We will soon publish an API that we think is a decent API for the user plane on a bare metal BRAS. We will publish it, and then we solicit feedback, and then we see where we take this, whether we adapt it or whether we bring it to the ONF. There needs to be consensus. So the guys in Madrid or wherever, they should use the same thing that we do. Actually, currently, we have already published our code for programming BNG on a certain chipset. Contact me, I'll provide you the link. System design, there's two major players, maybe more, but I'm listing two here, the ONF, the SEBA group, and the Broadband Forum. Hardware specification, as Thomas said, we did already provide to the Open Compute project an OLT specification. There's TIP, and Axel is chairman of TIP, so we're well represented there. Device drivers is currently happening at the ONF. But community is important for us, it's really important. And also we increase our activity, because community doesn't mean for us, oh, the community brings everything to us. We have ramped up resources, we have hired people, we're bringing stuff to the community. Okay, coming to the summary. Okay, so as I said, this is a strong community and we're part of that, we're proud to be part of that. So the access network redesign works. We have installed Chord, and it's like, Chord, okay, maybe a bit academic. How about changing this and that? And ONF is also moving to SEBA now. Now it gets more applicable to carrier network. The prototype is running. You can see it in our labs. You can see it in the field, in a limited field trial, but it's working. We have a BRAS on bare metal. Open hardware, open software changes a lot. We'll see at what time things move, but I don't think this is avoidable. This is going to happen. This is really similar to the PC industry. And one important thing is we can do quite some stuff on our own, but not everything. We need partners. We need partners for operating system support. We need partner for delivering carrier-grade code. We need partners for system integration. Still, we want to be at least in charge of what is being done. As Thomas said, the business logic, that's a key point for us. The thing that determines whether we are fast or slow on the market, that is something we want to do in-house. I don't want to having to talk to 5 different vendors about adding a small feature. We want to do that on our own, and we have done some prototypes where we already executed this. There's still room for extreme cool technology, for instance, on the chipset side, also on oh, I won another 10 minutes? Cool. Something's wrong with the clock. Okay. I can talk for hours, no? My family knows that. No, this is the last slide. And there is a lot of space for what we call hard-to-copy technology. In Deutsche Telekom, we are able to develop an SDN application. Yes, we are. We can do this. We can do this even carrier grade. But are we able to do a fully fledged, complex EPC or BNG control plane? I think not. Do we want to do this? Maybe not. So let's wrap interfaces around that and APIs and make sure they become interchangeable. For instance, EPC, you can run multiple instances for multiple use cases, like an M2M EPC, like a mass market EPC, hybrid access EPC, and so on. So what's ahead of us? We productize this with partners. We're choosing some partners. It's not going to be the decision for the next 100 years, but it's the partners for the next round. That is important for us. We want to foster the ecosystem. About the business model, we also want to hear feedback, honest feedback. If somebody says, hey, Hans, this is not the right thing to do because of, don't tell me this is the wrong thing because it's the wrong thing. That I heard often enough. If somebody comes and says, this is wrong because of, and here's why, that's the kind of feedback I'd like to have, and then we'll check if we're still on the right track. Standards important, open source software, hardware drivers, OCP. Yeah, let's do this together. So if somebody's in the room who hasn't heard about that and thinks like, hey, I want to be part of this, let's talk, right? Part of the community or part of our project, both possible. And yeah, this is a long transformation. And we are in delivery mode. We've played with it, or we've seriously worked on that for 2 years. We know it's in principle working, but now the trick is to move from the lab out to the field. We're on the way. We're like one step already in it. And to make this run and make this a success for our network, but also for the community. Before I stop, Thomas, did I forget anything?
No, it's all good.
Okay, this was
you
the last slide.
You addressed the main points, and that's
We
perfect.
still got 7 minutes. That's exactly the time you need for a beer, right? Okay, thank you very much.